Assalamu alaikum wa rahmatullahi wa barakatuh. Today our lesson is about isosceles and equilateral triangles. In this lesson you will use and apply properties of isosceles and equilateral triangles. So let's see here, girls. I want you to look at this triangle. How can I classify this triangle? Okay, so you classify the triangle based on the length of its sides, and you can also identify certain triangles based on information about their angles. We took this before. In this lesson, you will learn how to use and apply properties of isosceles and equilateral triangles. Okay, let's recall what we took before. If I classify the triangle by its side, and if the three sides are equal, then what we call it? We call it, of course, equilateral triangle. If two sides only are equal, so what we call it? We call it isosceles triangle. Okay, and if the three are not equal, then we call it what? Scalene triangle. Let's see next. Okay, the lesson vocabulary here. I want you to look at this triangle. They put here the mark on only two sides. That means, what kind of triangle is this? Isosceles triangle, is it right? Okay, so let's name this one. Here, this is, we call it vertex, and about the sides, we call them what? Legs. And then here, this is the base. This is leg, and this is the other leg, and this is, we call it base, okay? And the two angles here are base angles. So let's read here the definition of each one. Isosceles triangles are common in the real world. You can frequently see them in structures such as bridges and buildings, as well as in art and design. The congruent sides of an isosceles triangle are its legs. The third side is the base. The two congruent legs form the vertex angle, and the other two angles are the base angles. Okay, so let's see next. Theorem 4-3, isosceles triangle theorem. What is this theorem? If two sides of a triangle are congruent, then the angles opposites those sides are congruent. So if the two sides are congruent, then the base angles are congruent. That's it. This is what we call it, isosceles triangle theorem. Okay, girls? Let's see next. Here, prove the theorem. Look at this triangle. I want you to look at this triangle. Here, they gave you that this side is congruent to this side. And XB, they wrote it here, given XB, this bisects the angle YXZ. So they ask us to prove that angle Y congruent to angle Z. I told you always, we start our proof by what? By the given. So this is the given. XY congruent to XZ. This is given. And then by the definition of angle bisector, because angle bisector, you know what is the meaning of angle bisector? Of course, this bisector bisects the angle into two equal parts. Is it right? We know this. We took it before and we did a lot of exercises about this. So, by the definition of angle bisector, angle 1 is congruent to angle 2 by what? By the reflexive property of congruence. So, XB is congruent to XB. This is what? Because it's what? It's a common side, and we know that any side is congruent to itself. By what? By the reflexive property of congruence. So by the SAS postulate, the two triangles are congruent. If the two triangles are congruent, then the corresponding sides and angles are what also are congruent. So angle Y is congruent to angle Z, since corresponding parts of congruent triangles are congruent, and that's it. Okay, so let's see here next, theorem 4-4, the converse of the isosceles triangle theorem. This is the converse. So if they give you that the two base angles are congruent, then the two sides are congruent. That's it. Very easy and simple. Let's see together problem 1 using the isosceles triangle theorem. Okay, let's see question A. Is AB congruent to CB? Explain. Okay, I want you to look at this triangle now. They said AB. Is it congruent to CB? Okay, so they give us that this side is congruent to this side, and they put the mark here that angle A is congruent to angle C. So we can use which theorem? We can use the converse. Yes, the converse of isosceles triangle theorem. So we can say that since angle C congruent to angle A, then by the converse of the isosceles triangle theorem, we can prove that AB is congruent to CB. That's it. Let's see next, question B. Is angle A congruent to angle DEA? Explain. Angle A, this one, congruent to DEA. Okay, let's see. Look at the small triangle, all of you. They put the mark here on the sides. So you can understand that the two sides are congruent. So by using the isosceles triangle theorem, yes, we can say that angle A is congruent to angle DEA. That's it. So let's see here together. After this, got a number 1. Question A, is angle WVS congruent to angle S? Is TR congruent to TS? Explain. Let's look at this triangle. Okay, they said angle WVS congruent to angle S. So look at this small triangle. They put the mark on the sides. So you can understand that if the sides are congruent, if two sides are congruent, then the base angles are also congruent. So yes, the answer is yes. Let's see the other part. Is TR congruent to TS? TR is congruent to TS. Okay, we did this before. So they put the mark here that R is congruent to V, to WVS, okay? And we, in the previous answer, we said that angle V is congruent to angle VSW. Is it right? So we can say that angle S is congruent to angle SVW is congruent to angle R in the big triangle. So from this, we proved that angle R is congruent to angle S. And we know that by the converse of isosceles triangle theorem, if the base angles are congruent, then the sides are congruent. So TR is congruent to TS. Okay, let's see. Question B, reasoning. Can you conclude that triangle RUV is isosceles? Tell me, huh? Think about it. Can we prove that or not? If we don't have the other triangles, can you prove it? If they put only one mark, is it enough for us? No. So the answer here is no, we don't have enough information. Okay? Okay, let's see next. Here we have Theorem 4-5. In this theorem, let's read. If a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. So look at this triangle, all of you. Here we have. If they put the mark on AC congruent to BC, and they give you here that the angles are congruent, that means here you can understand that CD is what? CD is bisector, is it right? Why? Because it bisects angle ACB into two equal parts. Then you can understand that SD is what here? Perpendicular on AB, and the segment AD is congruent to DB. Of course, if the bisector bisects the angle into two equal parts, then it will also bisect the side here into two equal parts. Okay? Let's see next, problem 2, using algebra. Okay, the question is, what is the value of x? Okay, I want you to look at this triangle and tell me. Here, they put the mark, so you can understand that this triangle is what? Isosceles, is it right? Okay, they put the mark. So you can understand that AB is congruent to CB. Okay, they give you here, this is angle X, and they put the mark. That means this angle is congruent to this angle. Okay, and they give you here 54. This is the measure of angle A. The question is, what is the value of x? I want you to look at this triangle, girls. I want you to look at this triangle. Here. Can you tell me what is the measure of this angle? Okay, it's clear that by using the previous theorem, if this line, if the bisector bisects the angle into two equal parts, then this bisector is what? Perpendicular. Is it right? So if it's perpendicular, then you can understand that the measure is 90. So if I have this 54 and here 90, can I find this? Of course, yes. By using what? We know that the sum of the angles in a triangle equal what? Equal 180, is it right? So to find x, we need to add this number to 90 to this, okay, equal 180. So here we will add angle A and angle ADB plus angle DBA equal what? Equal 180. So here we will substitute, and then we'll find that 54 plus 90 is what? Is 144, is it right? So this equation will be 144 plus x equal 180. Then to solve it for x, we will subtract 144 from each side. So the answer is x equal 36. Okay, let's see, got it number 2. Suppose measure angle A equal 27. What is the value of x? So in the same triangle here, if they change this 54 and they give 27. So what we will do, how can we solve it? Of course, you will follow the same steps, okay? But instead of writing 54, you will use 27. So it will be 27 plus 90 plus x equal 180. Then you will subtract from both sides to get the answer. Okay, so the answer here is 63. That's it. Let's see this. A corollary. We took it. What is the corollary? Let's recall what we took before. Is a theorem that can be proved easily using another theorem. Since a corollary is a theorem, you can use it as a reason in a proof. Okay, so let's see here the corollary to theorem 4-3. In the triangle, if they give you that the three sides are congruent, then the three angles are congruent. The corollary to theorem 4-4, if they give you that the three angles are congruent, then the three sides are congruent. Very easy and simple. Let's see next. Problem 3, finding angle measures. Okay, in this question, what are the measures of angle A, angle B, and angle ADC in the photo at the right? So I want you to look at this figure. Okay, they put here that the sides are congruent. So you can understand from this by using the previous corollary that the angles also congruent. So if this is x, this is also x, this is also x. Is it right? So here, to answer this, they wrote here, let A equal measure of one angle. So in one triangle, we have how many angles? 3. So 3A equal 180. Then we will solve it for A by dividing by 3. Is it right? So the answer will be A equal 60. And because we said that all the angles are congruent, then the measure of angle A equal to measure of angle B equal 60. Very easy. And then they said here, what is the measure of angle ADC? ADC. This big angle. Okay, this one. So what is the measure of ADC? We know that this is 60 and this is 60. So can you tell me what is the measure of the big angle? Of course, 60 plus 60 equal 120. That's it. Okay, let's see now. Got it, number 3. Suppose the triangles in problem 3 are isosceles triangles, where angle ADE, angle DEC, and angle ECB are vertex angles. If the vertex angles each have a measure of 58, what are measure angle A and measure angle BCD? Okay, so let's see here. Look at this triangle, this picture. Okay, they said isosceles triangles, so you can understand that the two sides are congruent. So this is congruent to this, is congruent to this, and this. Is it right? Let's say it again. This is congruent to this, congruent to this, and this. Okay, so they said the vertex angles each have a measure of 58. Okay, so they said here angle ADE, this angle is what? 58. And angle DEC, this angle is also 58. And angle ECB is also 58. Okay, so they said what are measure angle A? This is missing. And the measure of angle BCD, this big one. This big one. Okay, so let's see here. How can we answer this? Okay, look at the triangle. Look at this triangle. If I put the mark on this and this, So you can understand that the two sides are congruent, is it right? And by using the theorem, you can say that angle A and angle ADE are congruent, is it right? So by using also the sum of the angles in a triangle equal what? Equal 180. So what we will do here is, this we know it, which is 58. And here, if this is x, this should be x, is it right? So we will use, after using the sum of the angles in a triangle equal 180, we will write x plus 58 equal 180. And then this is the answer. X plus 58 equal 180. And then x plus x equal what? Equal 2x plus 58 equal 180. Then to remove this 58, we will subtract 58 from both sides to get the answer 122. Then to solve this for x, we will divide by 2. Is it right? And then the answer is x equals 61. And we said before, this angle A is congruent to AED, then the two angles are congruent, so they have the same measure, which is 68. Okay, now let's find the measure of the big angle, which is DCB. If you know that this one is 58, and this one you found it, which is 61. So to find the big angle, you will just add 58 plus 61 to get the answer 190. That's it. Okay, the last question in this lesson, error analysis. Let me read. Claudia drew an isosceles triangle. She asked Sue to mark it. Explain why the marking of the diagram is incorrect. I want you to look at this figure and tell me why we have the error here. We have an error. Tell me, where is it? Okay, look at the sides. AB is congruent to AC. So, where is the mistake? Of course, this one. Is it right? Because angle A here is a vertex angle. Is it right? And we took from the theorem, we understood from the theorem, if the two sides are congruent, then what? The base angles are congruent. So the mark should be on angle B. That's it. I hope you understand this lesson very well, like in the class. Best of luck.